Hey everyone, Kris here with Borensten, who heads up all of our data science program, AI, ML, things like that. We have a bunch of cool things that we're going to show you that we do for model training, like in the guts actual stuff. But before we do that, Allie, why don't you explain why model training is really critical to the whole thing?
Yeah, and I will use our time in transit model as an example here. So here we're trying to predict the time that it takes for a shipment to get delivered to a destination. And as you can imagine, this is something that's not static. It changes over time. And so the beauty of using a machine learning model for this is that we can train our model on vast amount of historical data so that the model can really learn and adapt over time to those changing patterns. And that is, really some of the core value that we're able to provide to our customers. And it's all done through our regular retraining processes.
So we're going to switch over and show the actual pipelines within Git and things like that. Before we talk about the pipelines, in like 20 seconds, what's the importance of the data as like the starting point?
Yeah.
Like, how does that feed into this?
Absolutely. So a model is really as good as the data that it is trained on. So there are a few really key components of thinking about data and how you are ensuring that it is validated and of high quality. That is all really what the model has to learn on. And then the other key piece to consider about data is how you aggregate across different sources. For example, we have our shipments data, we have our tracking information, and the real key part here is how we combine all of that data and engineer new features to provide the model with additional signal to predict outcomes.
Awesome. So let's walk through an example of an actual model. This is our carrier selection TNT model, which has a composite of several models underneath. And this is just our August test, one of dozens that we do. Why don't you walk through the hypothesis setup and how you do the arguments and things like that?
Yeah, absolutely. So with every model, the key first step is really trying to understand how to frame the model objective itself. So what are we trying to predict? And then how do we select the appropriate algorithm for that? As well as how to set up our loss function. So the objective of any model is really to minimize the loss, right? We want to reduce the error rate. And a lot of that has to do with how you use hyperparameters and how you tune them. So what you see here are examples of those hyperparameters and how we've tuned those over time as we are going through our model training process to ensure that we are delivering the most accurate predictions.
So this goes through a pipeline then, right? And we start with a hypothesis, these arguments, everything's kind of calibrated. But what about the results when it's done? I'm going to switch over to this tab because this was really fascinating to me too.
Absolutely.
So let's walk people through what you're looking for in the results of the training exercise.
Yeah, absolutely. So one of the biggest considerations when you're training a model is that you want it to be robust enough to generalize well to unseen data. So a lot of there are various approaches for how this is done, but what is key to any model training process is that you have what's called a holdout data set that you are looking for various metrics and results on to really understand, is this model going to do well when it's put into production? And so as part of our actual pipeline itself, we have automated reporting that gets generated that goes into extremely granular detail, as you can see here, across various metrics, a lot of which are custom built for this model itself, so that we can really do a lot of slicing and dicing to understand how the model is performing on various segments, as well as how we think it's going to perform on unseen data, because this is using the holdout data set.
Cool. So let's finish it up by explaining what's next. So let's say this model test performed well. What happens?
Yeah, absolutely. So again, here we're seeing in action the pipelines that are running that take us from the various stages of training the model to planning for deployment, and then finally to the actual deployment itself, where we are deploying a new model to production to be used for real-time predictions of transit times. So that's what you see here.
We'll talk about deploying next. Thanks. See you, everyone.